Let's talk about a concept called a networked object. A networked object. Imagine we're playing a multiplayer game and we have three clients playing this thing. And we'll say that this is a racing game. And these are the screens of the three players. I'm here in New Hampshire, someone else is in New York, someone else is in Florida. And this is what's pictured on our screens. Currently just blank, empty, right? And the game starts. And I spawn a car that represents me, that I'm going to be driving around with my controller. My car is right here. It's a black race car. This black race car, we want to also be represented on your machine and on this machine over here, right? It'd be awkward if only I could see this, even though we're all looking at the exact same game. So what we would actually see is something that looks like this. My car would also have a representation on your machine, and my car would also have a representation on this third machine. This, remember, is three separate applications running on three separate machines at various places around the internet. This game object that's being run in this simulation is not the same game object as this one running in this simulation. And it's also not the same game object as this one running in this simulation. These are three separate computers running three separate applications. It just so happens that when I spawned mine, I sent messages to everyone else saying, hey, here's the car I'm spawning, here's the position I am, here's my orientation, here's what I look like, and you guys should go ahead and spawn something that looks the same. This is the idea of what a networked object is. It's an object that is replicated across all of our machines and is sort of like this shared representation of this instantiated object within the simulation that we're playing, right? It is important to keep in mind that these are three separate objects on three separate machines, and we are all running our own simulations. I've got my physics going on in audio, and you've got your physics in your audio, which may not be exactly the same. But this object here, this object, because it's a networked object, there's a lot of concepts that go along with that. One thing about it is typically network objects have some sort of unique identifier associated with them. We'll say that this is object number 1. And this object number 1 would have a shared ID on all of these machines. The reason why this happens is because whenever I send information about object 1 to the other machines, we need to know which object it is specifically that I'm talking about. If my first client says object 1 is moving forward by 5 feet, this machine and this machine need to know exactly what object it is that I'm talking about that can move forward by 5 feet to keep it all in sync. The next thing that these objects typically have are messages and being able to send messages back and forth to one another. This object here typically would have the ability, because it is a networked object in our networking system, would probably have the ability to send a message to this exact same object on the other clients. So we'll see that. When we look at remote procedure calls, we'll see that this object has the flexibility to send remote procedure calls to these other individual objects on these other clients. Or it could send a remote procedure call, which goes to our server, which I haven't even drawn here. There's a server we're connecting to, and then in turn comes back and is received by all three of these objects, right? In which case my object here may actually be having a little bit of latency, which may be desirable with when I'm sending those messages back and forth. The next thing that network objects frequently have is synchronized movements. If this car here decides to make a right-hand turn by some amount, right, the position and rotation and orientation of this object will then be sent over the network, and these objects, which have the same ID, should be synchronized along with it, so they all look and behave the exact same way. When we're playing online video games, we don't even think about this. This just happens naturally. Someone's playing the game and they run around and they hit jump and they jump on your machine. Someone fires their weapon or throws a grenade and they fire their weapon and throw their grenade on your machine as well. You see the same thing. In reality, you're actually seeing a slightly delayed version. I turn right, those messages about me turning right are going up to the server, they're going over the internet, and then sometime later, these two clients then get the exact same message and can then update their clients accordingly, right? Let's fill this out with a couple other networked objects. So let's say that I spawn this black car, and then here, this client wants to spawn and play as a blue car, which is at this position. They would spawn their car, and then let the other clients in the same way know that they're spawning their car, and it should be in the exact same position and have the exact same orientation. Lastly, this needs a unique ID. Let's call this object 2. One thing to note about this is that these unique IDs, if I didn't mention it before, these unique IDs are unique across the entire network, across all of the clients that we're playing with. This is ID number 1 for this object on each machine. This is ID number 2 for each object on each machine, right? These numbers need to line up. If they don't, we're going to be sending messages to the wrong objects. And then finally, we need another car for client number 3. Let's put it up here. And then the other clients spawn the same one at the same position. And this one would have a unique ID of 3. This is a very simple diagram of what networked objects are. They support sending messages, they have unique IDs, they have synchronized movements if desired. The last thing that I want to mention is sometimes this idea of networked objects doesn't actually need to be a visual object that you're seeing in the world. Networked objects, if you imagine anything that a game object in our simulations could be inside Unity or Unreal, an object doesn't need to be a 3D model that's moving around through our space. An object could be a logical container, like an object that's storing the state of the game, or an object that's storing a collection of information, who we're grouped up with, or maybe it's the current state of all the quests that we're currently on. We could use the idea of a networked object to maintain our mission log or a shared inventory. And that information could be synchronized between all the various clients by sending messages back and forth between them and sharing that same network object with that unique ID. Most commonly, they are used for objects like this, which are moving around through the world, but I definitely encourage you to think outside the box with what networked objects do, how they behave, and how you could potentially use them in the games that you're developing.